This is our engine building room, guys. This is where we assemble all the motors. It's a clean room. Stay away from, all the dust and metal shavings and dirt and stuff like that. It is temperature controlled. So we have about 5 or 6 motors that are being built at the same time. Pretty busy and a little behind, to be honest. Hopefully customers aren't so pissed off at me, but I'm getting them done. So what we have going on here right now is, this is a Mazda BP 1.8 motor. It's going to be turbo, so it's all forged internals. We used Wiseco 8.5 to 1 compression pistons, Eagle connecting rods, King race bearings, and committed gasket ARP fasteners. It's all assembled, waiting for the cams to go in, and new timing components, new oil pump, OEM oil pump, and then we're not putting the motor in the chassis. The customer is, but we just build the engine for him. So that's the process with that. But we are gonna fabricate some of the turbo kit parts once the motor is in the chassis, and then we're gonna go on the dyno and tune it for him as well. He's gonna be on Mega Squirt ECU. So that's the plan for that. What we got here is a K24 build engine for overseas customer. This is going in a road race application. So it's basically a track car, obviously NA. On this one, horsepower goal is about 300 horsepower to the tire, but we're trying to do it to where it's a useful power for road racing, because we need a wide power band for that type of track. It's a small track with a lot of turns, so he's going to need a lot of torque and a lot of low mid-range power to get the car out of the turn and be competitive, not so much high RPM power like a drag car. So the ITB, the length of the runner, the size of the runners are pretty much matched for a wide power band, versus having a huge ITB like drag cars run with a lot of top end power, not so much low end. So it's designed correctly for road racing. Over here, what we have is a Ford Mustang Cobra engine. It's out of a 2001, I believe, 2000 or 2001 Cobra. It's a 4.6 aluminum block, 4.6. I really love these motors. I mean, I've built a lot of these 4.6s from, back in the day. I've built a lot of them, iron block and aluminum block. And I just love the way they sound, the way they make power. I hope I don't hurt LS guys' feelings, but Cobra motors have always been one of my favorite motors. They're very efficient motors. I believe the main reason behind it is the cylinder head design. So this one is built for NA setup, but we kept the compression and the specs close to the factory specs, because he doesn't know if he's going to supercharge it or not. So I kept the compression ratio and the specs around the factory specs. Bottom end is all done. We used Manley forged pistons, Manley H-beam connecting rods with 7/16 rod bolts on it, factory crank, Clevite bearings, all new timing components and stuff, which they haven't gone on yet, but we were waiting for new cams to come from Comp. They were being custom made, which we received them a couple days ago. So we're gonna put the heads on, put the cams on, time it, and then bring the chassis over, put the motor in, and go on the dyno and tune it. And these are the head gaskets, factory head gaskets. So that's what we got there. Right over here we have a Hemi engine. This is out of a 2000 and let me see how good my memory is. I'm getting a little old, but I think it's out of a 2004 Magnum SRT. So originally they come with a 6.1. They're born with a 6.1 Hemi engine, but we put a Manley stroker crank in it. So now it's roughly about a 6.9 liter engine, 6.88 liter engine with that bore combination. Fully forged. This motor is very strong. It's built for twin turbo setup. Horsepower goal is about 1200 horsepower. So it's all done up. Pretty aggressive cam from Comp in it. Really strong ARP fasteners to hold the heads on, because we're going to be running some boost in this. And we used Manley pistons, Compstar Cali's crankshaft. Manley the stroker crank, Manly pistons and Manly connecting rods. I'm sorry, I was mixing this with the LS engine that I did recently, but yeah, it's all Manly internals, milling, high pressure, high volume oil pump in it. We got all Manly valve springs, retainers, comp cam, Manly push rods, all chromoly push rods, and heads are CNC ported, valve jobbed, blended by Arlington Machine. Really good machine shop that we use for all our machining work. And valves are also by Manly. So yeah, this is waiting for time, which we never have, to bring the chassis over, to put the motor back in the chassis and fabricate a twin turbo kit for it. So we are doing all the, basically it was a one full project from engine building, turbo kit fabrication, fuel system, and dyno tune. So engine is all done, waiting for the chassis to come in so we can fabricate the turbo kit. So that's that.
And we still have more all the way down there, huh?
Yeah, this is a K20 NA engine. The short block is assembled. That's also for road racing application. Short block is done. I'm waiting for the head to be done at the machine shop. We got the head ported and valve job. Waiting for the head to come in so we can assemble it, put it back in the car. This is actually for the shop vehicle. This is for the shop road race car. So we did a new engine on it. We use Mahle pistons, 12.5 to 1 compression, roughly about 12.6, 12.7. We're running Brian Crowder lightweight I-beam rods on it. Really nice rods. They're kind of new to the market. I love them. They're lightweight, very competitive. You know, weight versus strength. So I'm trying to keep the weight low on these motors, road racing motors, because there's a lot of RPM and a lot of RPM change and a lot of basically load going to the crankshaft and to the piston and to the connecting rods because of upshift, downshifts. Even though it's an NA motor, but there's a lot of basically weight matters a lot in rotating assembly when you do a lot of RPM change. So the crankshaft is also lightweight, knife edged by Castillo cranks. Took about 4.5 pounds off the crankshaft by cutting the counterweights off, and it's fully balanced. So can't wait to get that motor in the car and see how well it's gonna run. But on the previous setup, on a whole different setup, which was heavier rotating assembly with less efficient cylinder head, we made about 268 horsepower out of a 2-liter to the tire on a Dynojet. So on this one, if I could get about 275, 280 out of a 2-liter, I'll be super happy. I mean, that's a lot of power out of a 2-liter engine on an 86 crank. So we'll see how it goes, but the cylinder head that we're going to be using hopefully is going to outflow the old head and give us the power that we're looking for. But I mean, out of a 2-liter, I'll be impressed if I get that.
Yeah.
Plus, I also have a custom intake manifold. It's a second harmonic intake manifold that Joel McCarty, rest in peace, he was the original designer of that manifold, and this is basically from his idea that I'm using. And that manifold is very, very strong, very competitive with ITB. But the goal is I'm trying to beat the ITB power out of the manifold, but I haven't been able to. So far, the closest I got was 8 horsepower away from a Kinsler ITB, which for being a manifold, making 8 horsepower less than a Kinsler ITB, I'm actually surprised. But the goal is to beat the ITB with a manifold. So I'm going to make a new manifold and run it on that setup and see how much power I can get out of it. So.
Yeah, and then the track car that engine's being built is also going to be testing this same engine, correct?
Right, that engine, we're going to put it in the track car, which is a shop car, fully tune the engine, and then pull the engine back out, drain all the fluid, and then package it up and ship it overseas with the ECU with it. So when they receive it, it's turnkey. They just plug it in, turn it on, and go racing. So they don't, if anything, we just put it on a dyno, do a baseline, make sure airfield is good, it's safe for their elevation and their weather out there, because it's a whole different area. So
yeah.
But for the most part, I'm trying to make it turnkey for them so they don't have to go and tune it from scratch and this and that, and it makes it easier for both of us. Yeah. And it's a confirmation that the engine is doing good. I'll monitor the oil pressure and everything on the dyno, so I know when I ship it, the motor is good. So. But that's the plan with that engine, which is going to happen hopefully next week. Stay tuned for that. We're going to have some videos coming up for that, so it's going to be nice.
All right. Now, have we talked about the Raptor engine?
Raptor engine is at the machine shop right now. I can't wait to get that project going. It's a 6.2 Raptor. It's going to be bigger now. We're boring it over 30,000. But that's going to be an interesting project. So I'll keep you guys updated when I get the block back from the machine shop. I'm also doing a 1J build. There's the crank that we got back from Castillo fully machined, cleaned, polished, straightened, balanced, and got the oil galley plugs, got the oil galley balls out, tapped, cleaned, and put plugs back in them. So the crank is ready to go. I have the pistons and rods and block and everything. I just need some time to put it together. But this is going to be another nice build. Car makes about 570 to the tire. Pretty nice setup. So we'll see what it does now with the new setup.
What's the chassis that's going into?
Oh, it's a Supra. It's a 91 imported Supra. So
Okay.
it's from Japan. So
Okay.
it's right-hand drive Supra. So
And it's also gonna be tuned in here and
yeah,
everything.
we originally tuned the car, but I'm doing a new motor for him.
Mm.
So we're gonna retune it just to make sure everything is safe. He's on AEM Infinity ECU on E85. I believe. Yeah, it's on E85. Yeah, well, it's on Flex Fuel. So.
Wow, look at this. This engine room is amazing. Now all these are spare parts down here.
No, some of those are backup motors for the drag car, which I haven't drag raced in forever, guys. I'm sorry. I'll come back one day. I don't know when, but I'll promise you I'll come back one day. But those are all backup motors for the drag car. Yep.
How many motors are down there?
I have about 6 motors. Yeah.
Wow.
And those are all the cylinder heads that I have back up for it as well. So yeah, don't forget to like, subscribe, and
click the bell for notifications.
oh yeah, click the bell for notifications.
That's right. We're trying, guys. We're trying, right?
Yeah, we're trying. Yeah. But we're new. Sorry, we're
Yeah,
newbies. 17 years later, we call ourselves newbies.
Newbies.
But yeah, go ahead and like it, subscribe it, and I appreciate it. Stay tuned.